So we are getting ready to figure out each and every way that we can solve for x. Okay, so the first way we finished out in Unit 2A, which was factoring. Okay, so when I broke it down into something like x plus 3 and x minus 2, this told you that your x-intercepts were at -3 and +2. Okay. So that's one way to solve, is to factor and get your answers. Okay. Stop talking. Stop being rude. I've had enough. Okay, your quadratic formula is another way to solve for the x-intercepts. So anytime they ask you to solve for a quadratic, you're trying to figure out where does your picture cross the x. So again, one way was to factor. Another way was to go to your calculator and figure out where it crosses x. Another way is your quadratic formula. Okay, your quadratic formula is -b plus or minus the square root. Underneath the square root, you need to put b squared minus 4ac. And this entire thing, once you get that answer, is divided by 2 times a. Okay. So before you can use the quadratic formula, though, you need to have your equation in standard form. Okay, so where you get the a, b, and c values is from standard form of a quadratic. Ax squared plus bx plus c. Okay, so your coefficients, when it is in standard form, go into your quadratic formula to actually find your answers. And I'm going to show you how this all works. Okay. So the next part says, how and why does the discriminant work? Your discriminant is just what's underneath the square root. So your discriminant is b squared minus 4 times a times c. If you just use this part of your quadratic formula, that will tell you my graph never crosses the x-axis. My graph only touches it once, or my graph touches it twice. Okay, so if you end up where your discriminant is greater than 0, if the answer comes out to be greater than 0, you have 2 real solutions. Okay, so if you end up with a positive number, that means that your graph crosses the x-axis twice. It doesn't tell you where, but it tells you that it will cross twice. Okay, if you end up with it equaling 0, you have 1 real solution, which means your graph only crosses the x-axis once. So we've done greater than 0, equaling 0. My last one is less than 0. And if you have it less than 0, you have no real solutions. So these are one of those pictures where the graph is above your x-axis and never touches it, or it faces down and it's below your x-axis and never touches it. Are you all right? Don't die on me.
Oh, he's coughing.
Right.
I was going to be sick.
Okay.
Oh, Lord.
I want you to take this and fold it into the center. When we're finished, you're going to have a lovely diamond to put into your notebook. That was not supposed to fall out of there. On the outside.
Yeah, I know, right? Because everybody started coughing.
On the outside, please put discriminant is b squared minus 4ac. So you know what's underneath that flap. Okay. You know what's underneath that flap, and you can reference it when you need to. Y'all doing the fake cough like my daughter does. She looks at me, she's dying.
Because it's everybody's down like
you're freaking Mo out.
Capital B instead of like lowercase. I'm not taking it.
That doesn't help. Rebecca said it's okay. I'm not fake coughing.
I said I'm not good at fake coughing or coughing at all.
All right.
What do we put on?
Discriminant b squared minus 4ac. Just so you know what's underneath the flap. So when you go to reference this page, okay. So we're going to do an example of each one of these. Okay. So the first thing you need to do is you need to look at your equation and you need to tell me what is my A value, what is my B value, what is my C value. If you look at this equation, what value replaces my A's? 6x squared. So it's just a 6. You need more paper? You can grab another ream over there. Okay. So A equals 6. What does my B value equal? What number? 1. Okay. And finally, what's your C value? Negative 15. Negative 15. Okay, I'm pulling all of these numbers from the example that they gave you here. So again, your A is your coefficient that's in front of x squared. Your B is your coefficient in front of your x. Your C is the constant off to the side. Okay. All right, so chill. All right, so we need to figure out how many times does this cross the x-axis. So to do that, we plug it into b squared minus 4ac. Okay, we're going to use this formula. So every time you replace a letter, you're going to put the number in parentheses.
Oh, he died.
You see, this is why I didn't come to school for 3 days.
Okay. So when I replace B, I replaced it with the 1, which was my value of B. It goes in parentheses. That way, when you plug it into the calculator, your calculator does all the calculations correctly. You need to know how to plug it in for your calculator to be useful to you. Minus 4. Now I'm plugging in A. Again, it goes in parentheses. And then I plug in my C value. Again, in parentheses. Okay. So 1 squared minus 4 times 6 times negative 15. I need somebody to plug that in and give me an answer here, friends. What does that equal?
I'm gonna be Bro.
I'm going to need you all to stop dying.
They gonna think it's all fun and games, but I'm just in the room talking. And I ain't gonna stay out. So
361. 361. So 361. So is this number greater than 0, equal to 0, or less than 0?
Less.
Greater than. It's a positive number. So this means we cross the x-axis twice. which means I have 2 real solutions. So when you solve this, you're actually going to end up with 2 answers.
When we list them, does it matter which one goes first?
No, it will not matter which one goes first. So when you finally get your solutions, which we're not going to do today, you're going to end up with x equals some number and x equals some other number. Okay? You're going to always have 2 answers here when you have 2 real solutions. Again, we're not actually going to solve anything today. We will concentrate on that tomorrow. Right now, I just want you to be able to look at an equation and tell me it's going to cross twice, it's going to cross once, or it's never going to cross. Okay. So if you go to graph this, you could have 2 types of graphs. You can have one that looks like this, where it crosses here and here. Or you can have one that's upside down and crosses. Okay.
Just on one side, though?
It doesn't matter. As long as it crosses the x twice, it could be 2 negatives. So I can also have one that's completely on the right-hand side. Okay. As long as it crosses the x twice, no matter where it's at, it can be on the negative side of the x, the positive side of the x. It just needs to cross it twice.
Okay.
Okay. Okay. Everybody good with that? Can I flip it up?
Yeah.
Can you wait till we're done with notes? Okay. So flip this one up. And so you know what's underneath this? This is 2 real solutions. Okay. 2 real solutions.
Is there equations I gotta do
No, because you just use the discriminant every time. It just depends on your answer. You could put that it's greater than 0.
You should put greater than 0, less than 0 equals 0.
So you can put that it's greater than 0, and that means you have 2 real solutions.
Oh, and the other ones are less than 0.
Or equal to, depending on what we have. All right, here's my next one. We only have 2 more, okay? 2 more. So this time, I again need to find my a value. So what's the coefficient in front of x squared? 1. What's in front of x? 10. And what's the constant? 25. Yes.
You called a BX.
Did I?
It confused me.
I said what number is in front of x, which is your b value.
Oh.
Your b value is in front of x.
I feel
Trust me, there's things that I slip up on and y'all are like, huh? Yeah, it happens. I'm human too.
Yeah, like when Miss Harvey was in here.
Miss Harvey was in, oh yes.
Noticed. I think he was just nervous.
I do get very nervous when she walks in here.
Miss Harvey.
What?
All right, so again, we need to plug this into the discriminant to figure out how many solutions. How many times does this cross the x-axis? So when I plug in, I replace b with 10. I replace my a with a 1 and my c with a 25. Justin says this answer is 0.
The answer to that answer is gay. What?
Oh my god. That's funny because some of the
All right. So Justin said this answer is 0. When we have an answer of 0, this means it crosses
One.
the x-axis once. So we have 1 real solution. So when you actually do go to solve this, you're going to end up with x equals some number.
Just one number?
Just one number.
There's only one solution.
There's only one solution. And I will show you what happens when we have that.
It's straight.
The maximum.
No.
minimum is on the x-axis.
What was that
The
again?
maximum or minimum is on the x-axis.
Your max or your min is on your x-axis. So what happens is your graph comes down, the vertex touches the x-axis, and then it bounces back up. Or it comes up, it touches the x-axis, and it bounces back down. So your graphs for this one look something like this. It can even be right at the origin. Okay. So when you have one solution, that's when your vertex, which again, Elijah made known that that's your minimum or maximum, touches your x-axis. That's the only piece that touches your x. Okay.
At the origin, can it be the opposite way too, or no?
Absolutely. It can also be like this. Absolutely. Okay, so it can also look like that. Did it?
Yeah, I put mine.
Does anybody still need this up? Okay?
What? No.
You good?
Yeah, I thought you were talking about. I thought you flipped it already.
No. All right. So you're going to flip this one over and put one real solution. And it's when we equal 0. One real solution is when we equal 0. So what do you think the next one's going to be?
No.
No solutions. Okay? No real solutions. Okay. So again, we identify my A value, which is what? 1. What is B? 2. And C? 5. Again, we plug it in here to figure out what's going on.
What is the equation for last period? Like 0 equals or 0?
It's up at the top of the thing.
No, like.
Oh, the equal 0?
Yeah.
It's equal 0. Yes. I was trying to figure out what you. I'm like, wait, what?
Oh, nice.
So we plug it in here again. This time I replace B with 2. I replace A with a 1 and my C with a 5. It's negative 16. So that means my value is now less than 0, which means it does not cross the X. Does not cross the x-axis. So no real solutions. I will tell you this. You will have solutions. They're just not real. We're going to start into imaginary numbers. Oh, yes.
If they're imaginary, then they're not real, so that means they don't exist. So why
Yeah. Why can't I just come up with 85%?
So, your solutions. You'll end up with imaginary solutions. Okay, so we're going to introduce the letter I when we do imaginary solutions. The I stands for imaginary.
Imagination is something I don't have.
You don't have an imagination?
I have.
Everybody has an
You'd be
imagination.
surprised.
I don't have an imagination.
Okay,
I don't.
so your graph looks something like this. Or like this. Okay? If it's an upwards facing U, it will always be above the x-axis if you have no solution or no real solution. If it's a downward facing parabola, it will always be below the x-axis and it will never touch.
So can you be the opposite from the U facing downwards?
Nope.
No, because then it would cross the x-axis.
Can you say?
Then you will cross the x-axis.
Because if I do a downward facing parabola,
It's gonna keep on going down.
no matter where I put it, so if it starts up here, it's still gonna somehow come down and touch that x-axis. So in order for it to be a downward facing, it's gotta be somewhere down here. It can cross the y, that's okay. It just can't cross the x. So downward facing always has to be below the x, and upward facing always has to be above the x.
How do we tell if it's downward?
How do you tell what?
If it's downward or upward?
An upward facing has a positive a value. A downward facing would have a negative a value. So in order for it to be an upward facing U, this would have to be like something like y equals 2x squared. This would have to be something like y equals negative 3x squared. Okay. It has to be a negative to be downward facing and a positive to be upward facing. Okay, so if you fold that in, we're going to put no real solution. And it's going to be less than 0. When you're finished with that, you can go ahead and glue that in
52.
on page 52.
Doesn't matter how we do it.
No, I don't care as long as it's on page 52.
Is that the only thing that's gonna be on page?
Yes, ma'am. All right. All right. So on page 53, is going to be your homework. So we need to set this up. I need you to pay attention. You are not going to glue these pieces in because they will not stay with that glue. It's not going to happen. It will fall out. So I'm going to pass around staplers. Okay. You're going to put 2 staples into each one of these. Okay. So pay attention. You should have all of these cut out individually. Okay. All right. So we need to make these into pockets.
Pockets?
We're going to make these into pockets. So you're going to take your paper and you're going to fold it on the dotted line. So the title goes backwards. Okay. So fold it so it ends up like this. Okay. So your title's on one side and the rest of it's on the other. Okay.
Wait, what did you like it? Oh, never mind. Got it.
Fold the title backwards. Okay.
Wait, what are like our line? Like facing.
That's fine. It's just where you creased it. It's not a big deal. Okay. All right. Once you have it like that, flip it over so it looks like this with the title on it. Okay. So now you're going to take these and fold them in. This is advanced paper folding.
I'm dead.
Fold your 2 side tabs in, so all you have left is your title. Okay. So you folded these 2 sides backwards in the back. So now you've got this little pocket right here. Pocket. Whoa! Look at that. Okay. Trust me, that glue is not strong enough. When we start, you're putting stuff into these pockets, so it's going to make them heavy, and it's going to fall out. I promise you. Okay, so take a minute and fold the rest of those exactly like that. All of these need to be folded exactly the same.
This is so cool.
Justin, who do you play tonight? East.
And it's here.
And it's here.
What time does the game start?
When we were referencing it.
Great.
I'm not gonna be there.
They are. Which is also why I'm going to give you paper clips.
Is this homework?
It's going to be. It's going to be, you're going to start it now, which you don't get finished. It's going to be homework.
So how do you really get around this?
First thing.
You need to fold it so the title goes backwards. I'll fold it there first. And then fold the sides. Thank you, Marissa. I have nothing else.
Can I finish off the staple?
Hold on, because I need to show you. Is it a big one? It's not gonna reach. It's a baby. It's not gonna reach. No,
This is mine.
all right. Everybody stop for a minute. Stop for a minute so I can show you where these staples are gonna go. Okay. I don't care what order you've decided to arrange these on your paper. My OCD mind goes no, 1, and 2. I've got to do it that way. That's my OCD kicking in. Okay. So I'm gonna staple in one real solution first. So you're gonna take the stapler. You need to go clear to this side, and you need to put a staple. Okay. Everybody see where that staple went? Okay. It's going to staple into the back side. Yeah, you're fine. There's a bottom part of the stapler, silly. It won't staple through 2. I'm lifting the page up.
Oh.
I'm lifting the page up. The stapler's going through the page.
Oh,
okay. You're also going to put one in on this side.
I told you I
Okay.
couldn't get educated.
2 staples in that one. Okay. On the top. Okay. Your stapler is not going to reach clear to the left side. So to put in that staple, I need you to come in from the top. Okay. So you're going to come in from the top and you're going to staple this one. Okay. So this one's going to have a staple at the bottom like that. And one from the side. Like that. Okay. So the top one needs to have one on the left, but it's going to be at the bottom because it doesn't go the whole way over. I don't have one of those long extended staplers. I'm not that fancy. Okay. I mean, if you can make it happen, go for it. I just went this route. Okay. With this one, it's the same issue. We can't reach it. So I come up from the bottom and I put a staple here and I come in from the side and I put a staple here. Okay, so I'm going to start one stapler over here with Elijah. I don't know, do you have the stapler over there? Daniel's got the stapler from over there. Make sure it makes it around to everybody. I told you it wasn't. I tried to tell you.
That guy has to go to the bathroom.
It's just gonna be a minute before the stapler makes its way to you.
You gave me an empty staple.
Huh?
You gave me an empty staple.
Did you figure it out?
Yeah.
For the one. Which fancy one today? Why can't I open this? Ah. Elijah, I'm just saying.
I got you with both.
Oh, are we supposed to like?
Ours is kind of like 500.
If we don't complete.
Everybody's gonna make one.
We're gonna talk about it.
There's like food.
Is this due tomorrow?
Yes, ma'am. Because you're gonna have the rest of the period to work on it, which is a good 25 minutes.
Okay, so let's start. I can't do it. Wait, we cut these out. Wait, are we cutting these out?
You're going to cut them out.
Right now? Each and every one of them. Oh, darn. Can I skip? So when do we start? I'm confused. All of these equal 0. Why does all of this say they equal 0?
What are you doing now?
Title page.
Did you stop recording? Miss Smith, did you stop recording?
So I can do the explanation of what y'all are doing. All right. I know some of you are still stapling, but I need everybody to stop for a minute. Okay. All right. So this is your sorting activity. This is your homework. You will have the rest of the period to get started. That is 25 minutes. Okay. You have time. Each one of these is going to need cut out, but you first need to figure out what pockets they go into. So you cannot lose them. So if you take a look at number 1, how many times does this picture cross the x-axis?
0.
0. So what pockets does this go in?
No.
No real solutions. So you'll cut that out and put it in no real solutions.
Why does one say no real root?
No real roots, no real solutions.
Okay.
Same thing. Remember, A root,
Zero.
solution, zeros, and x-intercepts all mean the same thing. Okay?
So it's the first one.
It's the no row solution. Okay? When you get to one like number 2, okay, you need to use that discriminant to figure out what happens here. So my A value is what? 1. My B value is 4. And my C value is 4. You're going to plug it in. So B squared minus 4AC. So we plug in a 4. 4 squared minus 4 times 1 times 4. So that gives me 16 minus 16, which gives me 0. So what pocket does number 2 go in? It equals 0. 1 real solution or 1 real root. Okay? If my discriminant is a positive number, that means it's what? Greater than 0. So where does that go? 2 real solutions. You need to sit here and put these where they belong. Okay, so the first 2 pages are super easy. Because you guys are honors, I also gave you this page. Oh, it is fair. All right, so we're going to do 31 together so I get everybody where they need to be. Okay, all right. So let's do 31 together. So I've got 9x squared minus 2x equals x squared plus 3.
Why is this so hard?
It's not that hard. I'm still recording.
Oh.
I'm still recording, so you have access to it. Okay, so the first thing you need to do is get this equal to 0 first. So I need to move everything to one side of the equation. So we want to move x squared across. So if it's positive over here, when it goes across the line, it becomes negative x squared. So that gives me 8x squared minus 2x equals 3. Okay. I also then need to subtract 3 to move it to the other side. So I finish with 8x squared minus 2x minus 3 equals 0. Remember, your 3 is not an x term, nor is it an x squared term, so it doesn't go with anything. So now you plug it in to b squared minus 4ac. So negative 2 is my b, minus 4, that's an 8, and my c value is a negative 3. So let's see, this becomes 4, that's going to be plus, that's 32 times 3 is 96, okay, that's going to give you 100. Yes, okay. That's going to give you 100. So that means that this one goes in the 2 row solution. Okay. So, if you need a picture of this, so you remember how to do this last page, okay?
You already know.
Make it equal.